Okay, welcome everybody. In this video, I want to think about how we can carefully read these stacked bar plots, and in particular, um, these relative frequency stacked bar plots. So in the previous video, we ran this code cell above, and we created this stacked bar plot, which mapped. So we had this penguins data frame. We mapped species to X. We mapped sex to the fill. So we had 3 bars, one for each species. And above each species, we had 3 different fill colors, one for each sex. And we have 3 fills for sex because we have male, female, and NA. We have a missing category as well, since there were some observations that were missing sex. And when we set the position to fill, so we don't use the default position stack, but we set the position to fill, it changes the vertical axis from counts to a relative frequency. And so it sets all of the heights up to 1. So it's giving me these frequencies relative to the totals for each species. So this is telling me out of all of the total number of Adelie penguins, what proportion of them were NA, what proportion of them were male, what proportion of them were female. Out of all of the chin strap penguins, what proportion were male, what proportion were female. If we switch the sex, if we switch the aesthetics between species and sex, and so now I put sex in the X position and species is mapped to fill, and I take a look at what happens, right? So now we get female, male, and NA on the X-axis, and above each of those 3 sexes, we're going to shade in different fill colors corresponding to each of the 3 species. Then we get a different looking plot, and we want to be really careful about how we read this. So now these relative frequencies are in regards to the totals for each of the sexes. So this is telling me, like, out of all of the females, what proportion of females are Gen 2, chin strap, or Adelie. So if we're looking at the blue bar up here, the middle blue bar in this plot up above, its height is about 0.5. Then this is telling me out of all of the chin strap penguins, 50% of them are male. So if you're familiar with conditional probability notation, this is saying, like, given that we have a chin strap penguin, what's the probability that they're male? In other words, out of all of the chin strap penguins, 50% of them are male. If we're reading the green area in the middle bar over here, so this green area over here, and if you're curious, like, this height is about 0.2. So this is going from about like 0.3 up to about 0.5. So this height is about 0.2. So that's where this value 0.2 comes from. This is telling me out of all of the males in our data, what proportion of them are chin strap. So this is saying, given that we pick a male penguin in our data frame, what's the probability that they're chin strap? So out of all of the males, what proportion are chin strap? That's 20%. So you just want to be really careful how we read these stacked relative frequency bar plots. We get a lot of information in here, and the ordering about how they're presented, how they're created, really affects how we read these plots. And so based on what information you're trying to communicate to somebody, that's going to dictate what you want to map to X, what you want to map to the fill. Okay, so that's we'll stop this video over there, and next we'll talk about how we can use the dodge position when we're constructing bar plots in ggplot2. Thanks.